Yeah, so I'm Tim Panton, CTO at Pipe, and yeah, you can see the logo. This is about a doorbell, actually. So the problem statement is I work at home office, which is at the back of the house, or on a nice day, I'll sit in the deck chair in the garden with a laptop and work there. Or I may be here in Berlin, or I may be in a co-working space in Manchester, or anywhere. But typically, if I'm at home specifically, the doorbell will maybe ring, and a parcel delivery guy has turned up, pressed the doorbell, written a note, and run out before I've got to the door. And so I just get the note and not the parcel. And I get to go and pick the parcel up from some inconvenient depot in the middle of nowhere at some inconvenient time of day. So I figured it would be nice to try and fix this. I'm not the only one to whom this, this kind of thing happens, I suspect. So I thought it would be interesting to try and fix it and then make a kit, maybe, of the result. So the user requirements, all good projects start with a set of user requirements, even voice over IP ones and certainly IoT ones. I want a doorbell to ring on my work computer at home. So when the button is pressed, that's what I want to happen. I want it to also work if I happen to be on my mobile on 4G, or on my laptop in the garden behind some NAT, or in a co-working space in Manchester. I want to be able to see who's at the door, but I don't want them, and I want to be able to speak to them, but I don't want to be able them to see me necessarily. Don't think that's a necessary requirement. And I may want to be able to lend access to this somebody else in the house. So, family, house guest, whatever. And in the future, I might want to unlock, say, a parcel bin beside the door, so that I could say to the parcel delivery guy, yeah, okay, there's a post box that's unlocked. You can put it in there, and buzz, or indeed, other people could use this for entry phones into flats. So those are the requirements, and here's the non-requirement. Thanks to Alison for this last-minute addition. Obviously, we want as few bugs as possible, and I don't want a motion sensor. This is actually a live, I won't show you the video, but it's a video of a bug triggering the motion sensor on Alison's Ring doorbell. You wouldn't want to go home if that was there, but anyway. So yeah, I don't need that feature. Operational requirements are, I don't want a new password to remember and store. I'm getting too old for remembering new things, certainly passwords. And anyway, it's an anti-pattern. I don't want to change or configure any of the networks. I can't go to my co-working space and say, hey guys, I want you to put a NAT pinhole through for me. Or I need to put this on your DMZ. It's not going to happen. I don't want to have to defend an auth server. So if this gets successful and there are 5,000 people using it, and I don't want all of their cruddy passwords collected in a MySQL database that I then have to defend. That's not I've got better things to do with my life. I don't want to have to pay for server bandwidth. Again, if this becomes successful and 10,000 people use it, I don't want to have to pay for their audio calls and their video streams. There's no reason for me to pick that up as a server bandwidth cost if I can help it. I don't want them to have to install a client app. Maybe they might want to, but I don't personally want to on my machine. I want to use a browser probably. And I don't want that data to be big dataed so that I get competing parcel services advertising to me because it sees an image with a DHL logo on it or something. I don't want to be in that position. So the net result of that is actually the whole design says I'm going to minimize the use of cloud services because all of these things come naturally out of using the cloud services. And I'm sorry, Dan, that's my kind of pitch on cloud. There are useful areas to it, but you have to be somewhat cautious. So I solved this problem by building some hardware. So this is what it looks like in its box. Inside, you've got a Raspberry Pi Zero, an SD card with Linux on it, obviously, a speaker, a relay, which I'm not using currently, but would be used for triggering the latch on the post box. An I2C amplifier for driving the speaker because the Pi W doesn't have a powerful enough, in fact, it hasn't got any audio output at all. USB microphone, which I cut the USB plug off because it fits in the box better that way. A Pi cam which fits in beautifully. And I want to say a huge thank you for my friends at Konstruktiv here in Berlin who do IoT prototyping. And they prototyped this box for me, and I went over there last night. We put the components in, we screwed them down, and it all fit beautifully, with the exception of the USB microphone, which they had never seen before, so we had to do a little work on. But the rest of it, perfect. So I want a big thank you to them. If you end up prototyping something, they're a great bunch. So, so actually, why would I mean, I ended up using WebRTC, but why? I kind of have to justify these things a bit. And I guess all of you know all of this, but I'll say it anyway. Like, it's a standard. It does NAT traversal, which is actually really important in this application. It gives me proper network independence. It's already in whatever it is, 2 billion browsers, so I don't have to install an app. And it supports media as well as data in the browser, which is kind of handy. It's got nice JavaScript APIs, so I can use WebDev and actually build an IoT UX using WebDev skills. And it's got good end-to-end security. So software stack, the problem with WebRTC is there's actually no well-known implementation for the Raspberry Pi. There's a browser that you can run Chromium on the Pi, but you're pushing things a bit. So we went out and wrote one. Well, I did. It's 100%, shares no code with either Chrome or Firefox, or indeed Edge. So it's it's an implementation that's completely separate from the spec. So we're using pipes, ice and stun, bouncy castles DTLS, pipes SCTP for the data channel, Phono, which I wrote actually while I was working for Voxeo, which is now owned by Cisco, RTP and audio, SRTP and audio, and pipes pairing mechanism for doing the security management. The whole thing ends up as 6 megabyte file and runs in 64 meg of RAM, which is actually quite nice on ARM. And you know, there's some shell scripts and other stuff around the edge, and a huge heap of node stuff around the edge for one small purpose. Right, yes, now. Linux on ARM takes a little while to boot, so we'll set that going. And hopefully, when we're ready for it, things will happen. So the setup and config, I want this to be really easy to use because I want normal people to be able to use it. I don't want to have to kind of get a network engineer in to do the config. I want it to be able to join the home Wi-Fi, and I want to be able to pair it with my smartphone or laptop. But this thing's got no keyboard. It's got one button, but I'm not doing it with Morse, thank you very much. So how do I get my credentials onto there, and how do I join the Wi-Fi when there's no keyboard or no screen? So decided that one direction would be audio prompts. And there's a kind of nice benefit for that, which was that, you know,
hello, I am your pipe-connected doorbell.
That it makes it feel like it's yours. It's like introducing itself. It's saying hello, and it's...
Once I'm set up and paired with your smartphone, you'll be able to use it to speak with visitors at your door from wherever you are, home or away. I need to be connected to your Wi-Fi and paired with your Android smartphone.
So we better do that, now we've been told. So actually, this is easier if you're using a smartphone than it is if you're using a laptop.
You can use the Nearby app on your smartphone to get started.
So on Android, there's a really nice app that looks for Bluetooth beacons and will start the app.
Now I am securely connected to the internet.
That was quick. You're not supposed to be yet. How did you do that? That's actually a bit worrying.
Alison is a smart lady.
Yeah, it's looking that way. Let's just see if she really is connected to the internet. A little diversion from the talk here. We're now in danger zone. James Bodie's test territory. No, she's lying. She's not telling the truth. Alison, you're not. Now we're in deep trouble. Okay, well. Oh, wait a minute. I've dropped off my Wi-Fi. That's why it's not working. Heck. Huh. Now we're in deep trouble. Yeah, hotspot stopped.
Even more trouble.
I'm in deep, deep trouble.
You can use the Nearby app on your smartphone to get started.
Yeah, maybe. Okay, so we're gonna come back to this in a second. Yeah, yes, excellent. Let's just give her one more shot to see if she's actually talking to the internet. I don't believe she is. Let's start that again. Right, let's give that one more shot. Go back to the presentation and come back to her when she's woken up. Right, it's actually, you shouldn't call things her. It's a thing, I'm sorry. Right, anyway, so the principle of this, when it's working, which it obviously isn't at this instant, is that you detect a Wi-Fi a Bluetooth beacon, and then the beacon starts sends you a URL which you browse to. And when you browse to the URL, you can load a thing called WebBluetooth, which allows you to talk over a very narrow bandwidth link to a Bluetooth device. And the idea is that we exchange some very few facts. We exchange the Wi-Fi SSID, the Wi-Fi.
Hello, I am your pipe-connected doorbell.
Excellent. That's a good start. All right. Are we still? Yes, we still have a hotspot. This might work this time. And then we exchange some credentials which validate me as the owner of the device. So we do a secure key exchange.
You can use the Nearby app on your smartphone to get started.
I can try. I'm not confident about this.
Great. Now I am securely connected to the internet.
I think that's really unlikely, but we'll see. So one extra point, which is that you need to allow notifications on your browser, but we'll see whether, nah, this isn't going to work. I'll come back to it. Right, so anyway, I can tell that anyway. So the idea is you've got a secured key exchange done like that. And in theory, it works everywhere. In practice, of course, it doesn't, as you've just seen. But you need stun and turn to make it work. Obviously, you need Wi-Fi, stable Wi-Fi. But it's nice. There's kind of lots of Chrome browsers that will support it. And in theory, we could do this on iOS with React Native. And you end up with end-to-end encryption. To get the button press, you need a notification to go out over a notification system, which is, you can't just leave.
You can use the Nearby app on your smartphone to get started.
You can't just use leave a connection open permanently. You have to use the Google messaging system to wake up an app on or a browser session. So you need to, in this case, I'm using Google's Firebase cloud messaging service, which is like, I didn't want to use the cloud, but I kind of have to for this. And it has a set of privacy implications, which I still need to work through. Like, I need to read the fine print about what data Google keeps when you push it through their system. I assume they don't inspect the messages, but who knows, I should look. And it kind of expects a server-based design. So this is essentially distributed end-to-end peer-to-peer architecture, and Google's expecting a design which is much more server-based. So it's not a brilliant fit, but it kind of works. We'll skip the demo for a moment. So you need to obtain the user's consent on the browser, which you just saw.
Great. Now I am securely connected to the internet.
Maybe you might be, I don't know. We'll try again in a minute. so that what we do then is having got that notification allowed, we push a token, it generates a token in the browser, which we push down the data channel that we've created to the device, which stores it. And then when you press a button, it pushes it back up to Google. Google notifies the browser notifies the user, and the user can then choose to click the link, which I'll show you in a minute if I ever get it working. This is the code for the button press on the device, which I absolutely love. Those of you who write shell scripts, you can write IoT stuff on a Raspberry Pi in shell. So GPIO mode 2 says that I want that thing to be an input, that pin to be an input. And then I sit in a loop, and that GPIO WFI wait for interrupt, it stands for, and it's a falling value. So when the voltage on that pin drops, on the edge trigger, that will wake up and it will send a echo 1 or something. And then I can trigger off some event, which is really sweet. And then that event can be playing audio or whatever, or in this case, taking a still and notifying the user that that still shot has been taken. So all of that is just like whatever that is, 8 lines of shell script, which I think is great. Okay, it doesn't work everywhere in practice. We need Turn. Worse yet, we need Chrome 60 for the most fantastically arcane reason. But it's a bug which arrived in 57 and is fixed in 60. So there's like a 3 Chrome iteration or 2 Chrome iteration break. WebBLE only arrived in 56 anyway, so it's like the 56 worked, and then everything stopped working until 60, whatever. Yeah, I'm kind of hoping Safari will do WebRTC, and I don't have to implement React.js, but whatever. And there's a hideous, for the Bluetooth stuff, that's actually all Node, and it's a hideous dependency hell, which I'm hoping Dan might help me fix at some point. And actually, some users just have Bluetooth switch off, which does make life a bit difficult. Anyway, so the idea of this thing is that it shows you an image of who's at the door, and hopefully at the end I will be able to show you that. And the browser establishes a camera data channel. So it just opens the data channel and says, read, requests a frame, gets a frame back, and we render it in JavaScript. So that's a really simple API. The audio, not so much. Any of you who are kind of committed web devs, just like blank out for 3 slides, because this is the VoIP bit. It's hideous, okay? So what we want is, we've already got a data channel, which has been used for getting the image and verifying stuff. So we don't want to, as Matt was saying, the whole WebRTC thing is that you multiplex as much as you can. Once you've got a channel up, you multiplex as much as you can over it to save the setup time and the hassle. So, and the risk of failure. So you can mux the audio on this already set up channel in principle. So I've got an offer answer that's gone past, and I can then send a second offer with an additional track in it, in the bundle, an audio track in the bundle, and that should start audio. It can be done, takes a full offer answer exchange, but I can send that over a data channel. I can open the data channel up and send that update over the data channel. Unfortunately, this requires 12 lines of STP. It actually only contains 2 facts, which is the codec that we're going to use and the SSRC number that you're going to use in the RTP header. But there are 12 lines of stuff that you randomly need to generate. Most of them are duplicates of things it already knows. So what I do is that the browser requests an upgrade over a data channel. And the nice thing about that is you get a 0 round trip setup of a data channel. That's the way that data channels work. And sends the new SDP over that. Sorry, sends a request for an upgrade. The device replies with just the 2 new facts that you need. And then in the browser, I take those 2 new facts. I take the existing SDP for the remote description, and I do a little ugly patching to generate what is the new offer. Push it down into the browser again, push the new remote description down again, and you're done. And as a side effect of that, I ended up writing in JSON a SDP Munge description language, effectively. So I have methods like action increment, so I can increment a field in SDP because I need to update the O number to get the next part of the offer. I can prepend lines above something, I can append lines after things, and I can duplicate lines. Because you can see down over on that side, actually, all of these things are duplicates. For reasons I don't understand, the bundle requires me to say all of these things twice. So, well, fine, okay, well, I'll do what I have to. It's ugly. And I just want to re-emphasize, if you're doing this with an image, the layout of that's wrong, but if you're doing that with an image, it's 5 lines of JavaScript to achieve what the previous, whatever that it was, 50 lines took. And this is 0 run trips. So now I'm going to talk a little bit more. So basically, the idea is that we wrap up, the pipe API will wrap up that SDP mess and just offer the web devs a nice experience so they can focus on that. But in tradition of, no, in the anti-tradition of IoT devices, we thought about the security. Unlike some, not all, but some. So one of the unique risks about a doorbell is it sits on the front of the house. So it's actually not that implausible that somebody would unscrew it and run off with it. And worse yet, if somebody surreptitiously could unscrew it, run off with it, take it home, analyze it, put it back overnight, and you wouldn't know. So there's a set of risks unique to, not unique, but specific to devices that sit outside your house. Things like, well, somebody might take the SD card out of it and copy it. They might plug into the USB port on the side and with a keyboard or a serial connector or something. And then when they do that, what can they get? Well, they can get your Wi-Fi password. They can get credentials, a set of credentials. Okay, you can obscure them, but in the end, they will get a set of credentials that's usable on your Wi-Fi. Maybe that's a problem for you, maybe it isn't. But it's a risk you have to think about, maybe. They'll get at least the last screenshot because that's still on the drive there. They'll probably get the last set of SDP because it might be in the connection logs. So you might get some IP addresses of where I was, might get the IP address of my co-working space or something. And it will get the pairing info with my smartphone or my browser. So there's some risks there about getting that stuff. Turns out the simplest way to address most of those, in the case of most casual thieves and hackers, is just to put a lot of glue in there. Like if you glue up the USB port and you glue down the SD card, and you put enough glue on the obvious test terminals, somebody's going to have to be pretty determined. And frankly, there are easier ways to break into my Wi-Fi than picking all the glue off my doorbell and replacing it without me noticing. So it's just leveling up a bit so that it's not too difficult. So my summary, and I will try one more shot at the demo in a minute. My summary is that IoT devices are peers, not clients or servers. It's an important way of looking at these things. They can hold their own authentication, but they don't necessarily want to be out publicly on the internet with public IP addresses. You kind of probably want them behind NAT and behind firewalls, but you want to be able to reach them through something like WebRTC. WebRTC can be run on a small Linux if you have the right stack and you've trimmed stuff down a bit, and it works reasonably well. Bizarrely, I'm living proof that it's possible for one person to write most of a WebRTC stack from the spec. Now, it's not a thing I kind of expect anybody else to be nutty enough to do, but it does mean that the spec is implementable, which is kind of important for things like W3C and IETF specs. WebRTC API needs to be wrapped for web developers. Like the idea of getting a web developer to go off and deal with that SDP is just laughable. They simply won't. And they'll go off and find something ugly like Flash to use instead. And if you get the right abstraction, then you can make that API really quite nice. So huge thanks to Alison for A, the bug, and B, the sense of humor of allowing me to use her voice in this box. Bouncy Castle guys for the DTLS, Foxair Labs for letting me play with WebRTC 5 years ago. 5 years. And it's been fun ever since. And oh yeah, and Taylor B on the Chrome team for the fix to the DTLS bug, which I thought I was going to have to write an entire EEX stack on the data channel or something. But then I went on holiday and came back and Taylor had fixed it. So that was like, whew, that was great. Right. Oh, and yeah. When this stuff works, it'll be on Pipe's GitHub for people to play with and build. Bit more info on Pipe there. And if you're IoT prototyping anything and you're in Germany, so specifically if you're in Berlin, do check out what Constructive can do for you. So I'm going to just do one. How are we doing for time? Yeah, OK. So I'm going to do one attempt at making this thing work. And if not, it'll turn into tomorrow's dangerous demo. So, and you could be thinking about questions while I'm at it. Like, why doesn't it work? So let's start that again. Yeah, so maybe I take a question while she's booting up. It is booting up.
Hi. I have a question. You said that you don't want to have a client app installed. And how did you achieve that on Android device? And what is the correlation between Android and the browser? I mean, what do you use Android device and the browser? Can you get the notification on the Android device?
So on Android, the easiest thing to do is just use Chrome. Right? I know it's a cop-out, but you can just have Chrome on Android does WebRTC and notifications just fine.
Hello.
So that end of it's kind of easy.
What if the Chrome is not in recent apps? It's not started. How will you get notification?
So the notifications are a piece of voodoo, but basically there's from every Android device, there's a permanent connection from that Android device to Google's messaging service, which will wake up whatever is associated with that. And if you associate Chrome with it, it will wake that up. Now, you can, and there's nothing to stop, and I probably would, build an app which then registers to receive that notification instead of Chrome and do it that way. But it's actually not strictly necessary. So, but notifications are kind of, I'm still learning what the limitations are. And as I say, I'm distinctly worried about the behavior of the way that they handle privacy, being Google. I need to look at that.
You have that working, right? At the moment, you have that working now.
Yeah, so I have it working, but I don't know what the privacy implications are exactly. So that's the piece I haven't researched yet, but that's next.
Okay, thanks.
I have a question here, chat.
You can use the Nearby app on your smartphone.
I'd love to, but you're not talking to me.
Did you, you mentioned that you thought about streaming the microphone. Did you think at all also about streaming the camera instead of just doing a snapshot?
Yeah, I thought about that a lot, actually. And the conclusion I came to was that the added value is limited. I mean, it's easy, technically it's easy to do, but bandwidth-wise, it's quite a challenge, and it's not clear to me that the benefit over capturing, what it's annoying is you haven't seen, but when you press the button, it captures, as you press the button, it captures an image. So the chances are, I mean, it's actually quite hard to press this button without, I mean, particularly if it's mounted on the wall, it's quite hard to press this button without, without getting your face in the camera, right? So you get that as part of the that data. And so I think motion is minimal. I think the added value versus the bandwidth consumption isn't worth it. I mean, it could change it, but that was my view so far.
Thanks.
Hey, Tim. I got a question about, so one of the things you mentioned was that you didn't want to handle the bandwidth, but at the same time, you also mentioned we need turn. So I have two questions there. One is, are you going to deploy turn for this? And second is, how do you pass this information over to the device? Do you do it on the initial handshake thing together with the Wi-Fi stuff?
Right. So yes, it will. I will have to run a turn service for it. But Pipe is going to have to run a turn service for all of the devices that are out there. Or Pipe licensees will have to do that for their own, depending on how that plays out. And the piece that's missing from this story is that you also need a rendezvous server. Like something has to do when to set your first data channel up, you have to have a common point to throw an offer answer through. So actually that point could also give you the turn credentials at the same point. The nice thing about the pipe design is that that thing knows no secrets. And in fact, the endpoints don't have to trust it. It just, because of the way we do the crypto, it never sees the media unencrypted, and it doesn't know anything that you're not prepared to have publicly, and you can tell if it's lying. Like you can tell if it man-in-the-middles you because of the way that we do the identity management. So, yeah, but yes, we need. You're right. There's a rendezvous server with turn and that we have to run. Hopefully, it's only like 5% of usage. So the bill isn't going to be too big for the bandwidth. There's one there.
Just out of curiosity, I mean, when you introduced the fact that you escalate the data channel only pre-connection to an audio thing, you mentioned that this was one of the bugs that actually forces now you to use Chrome 60, if I've understood correctly, rather than something else. So have you considered keeping it simple and always negotiate an audio connection since the very beginning and then only use it when it's actually going to be needed? I mean, it's kind of a hack. I mean, just to
so I thought hard about that, but whether I choose to speak to the person at the door is dependent on me having seen the picture, right? If it's kids or somebody trying to get money for a charity or something, I may just ignore it completely. So I don't, like half the time, I'm not going to set up an audio channel. But I do always want to see the picture. So I figure I want to set that up and bring the data channel in immediately, but audio optionally later. I did look at doing both, and I thought that was one of the things I was going to have to do, set them both up, but mute the audio. I thought I might have to do that, but as I say, when I got back from my holiday, I found that Taylor had fixed the bug that made it not work. And I thought, well, actually, I'm going to go back to my original design.
Okay, thank you, team, then. And tomorrow, dangerous demo.
Yeah,
right?
Yeah, afraid so. Just one more. Can't resist it.
Ding dong.
Thank you, Alison, then. Okay, so now we're preparing.